is number 103 in 2.5b. You want to make an open box from a rectangular piece of material 15 centimeters by 9 centimeters by cutting equal squares from the corners and turning up the sides. So like X represents the side length of each of the squares removed. Draw a diagram showing the squares removed from the original piece of material and use the diagram to determine the resulting dimensions of the open box. So here's what we're going to do. So let's draw the box first. So it is this dimension here, and we know that, let's just say this is 15 centimeters, and then this is 9 centimeters. But we're trying to make a box. In order to do that, we have to cut out these little corners, and they say that should be X and X here. Okay, so they're equal amounts that we're cutting off, and it's going to be an open box top. So then how you figure out these sides is that this is 15 centimeters, but we have to subtract out the x's, so it's 15 minus 2x. That is actually the length of this side. Then this one we have to do the same thing. We have 9 minus 2x because we're subtracting out these x's here. Okay, then what happens is this is going to fold up here, these sides. And so it's going to make an open top box. Okay, so I know it's not drawn to scale, but this is what it is making. Okay, so this type of box. So notice that what we cut out, that is actually our height of x. So this is, answer is here, is x, comma, 9 minus 2x, and 15 minus 2x. Then we're going to write the volume of the box. You're just taking each piece. And so that's going to be x times 9 minus 2x times 15 minus 2x. The domain is you have to see what is our restriction here. And so we know that the volume has to be positive. And so we think about where is it 0? So we know it's 0 at 0. It's also 0 at 2 over 9. And then it's also 0 at 2 over, I'm sorry, not 2 over 9. Let's fix that. That is 9 over 2. And this is 15 over 2. So at 2 over 9, that's about 4.5 here. And then at 2 is 15, about 7. So that's going to be here, 15 halves. And let's see, we know that this is going to be a cubic. So we know a little bit about the end behavior here. So we know it's going to do something like this. So we're looking at the volume of a box. We're looking at positive volume. So that's our y value, positive volume. And so we're looking at this area right in here. So we can't have negative volume, so therefore we cannot go here in this area past the 9 halves. So our domain in this case is that it has to be between 0 and 9 halves, or we actually put 0, 9 halves with parentheses. So that is the answer here. You would actually put this in there. So I hope that's a good start. Now, the next thing we need to do is we need to pick a graph. Since I kind of already graphed it already, we just need to find the graph that matches it. So we'll look in the next set here. We know that it starts at 0. So this first one is not the graph. This doesn't work. Neither does that one. And so the one that works, well, it hits the x-axis right here. So this is the answer in this case. That is our graph that we want. And it may move around depending on your problem because I know it looks different on my screen versus the one that I took earlier. Then now we need to approximate the dimensions of the box so we yield a maximum volume. And so one thing you could do is you could plug this into Desmos and figure it out. Another way to look at it is see the maximum volume is the highest that it is here. And so let me just give you that number just to kind of help us out in doing this problem. In here, it tells us that the max volume is 1.82. And then we also have 5.36. And then we have 11.36. Now, how you figure that out is that we get 1.82 from here, and then we just take this and plug it in to the equation, the x times 9 minus 2x times 15 minus 2x. So what I did is I just took this 1.82, plugged it in, so that's that first number, and then I plugged in 1.82 and multiplied it, and that's the second number that I had in here, 5.36. Then you plug in 1.82, and that gives you this last number here. Find values of x such that v is equal to 56. So what you're going to do is you set that up. So letter D, you do 56 equals x times 9 minus 2x times 15 minus 2x. And so what you're going to do is you're going to go ahead and multiply that all the way through, right? And you have to set it equal to 0. And so when you do that, this is 4x cubed minus 48x squared plus 135x minus 56. Then you're going to have to find the number to do the rational root theorem. In order to do the synthetic division here, we find that 1/2 is the answer, and then it factors after that. Let's see. And so once you do this, you'll get a value here, and then you're going to need to factor it, and then you come up with 3 numbers. So 1/2 is one of them, and then there's 2 more. Then once you put that in here, you see which one doesn't work, okay? And then why doesn't it work? So I hope that one helps out this problem. Thanks for watching.